In this video, we're gonna talk about angles and angle measurement, relationship between linear and angular measures of central angle, the unit circle, and the circular function. We start with the notion of an angle. An angle is defined as the union of two non-collinear rays with a common endpoint. In trigonometry, angles will be discussed in a different perspective. Angles will be thought of as any amount of rotation generated when a ray is rotated about its endpoint. The initial position of the ray will be referred to as the initial side of the angle, and the position of the ray at the end of its rotation will be called the terminal side of the angle. The arrowhead is pointed at the terminal side. The endpoint of the ray is the vertex of the angle. The direction of rotation of a ray also affects angle measure. If the rotation of the ray is counterclockwise, a positive angle is formed. If the rotation of the ray is clockwise, a negative angle is formed. An angle is said to be in standard position if its vertex is at the origin of a Cartesian coordinate plane and its initial side is along the positive side of the x-axis. This is an example of an angle in standard position. The initial side lies on the positive side of the x-axis and the vertex is at the origin. Examples. Let us determine whether each angle is in standard position. This angle is not in standard position since its initial side does not lie on the positive side of the x-axis. Here, the initial side lies on the negative side of the x-axis. Pero kung nandito ang arrowhead, this will be an angle in standard position. How about this angle? Since the initial side is located on the positive side of the x-axis and the vertex is at the origin, this is an angle in standard position. Similarly, this one is also in standard position. Clockwise direction, this is a negative angle. Another example. This is also a negative angle since the direction of rotation is clockwise, and this is an angle in standard position. Initial side on the positive x-axis and vertex at the origin. However, this angle is not in standard position. Take a look at the position of the arrowhead. Pabaliktad siya. The arrowhead is not pointed at the terminal side. Hence, this is not in standard position. This angle is also not in standard position since its vertex is not located at the origin. So that is how you determine if the angle is in standard position. On the other hand, a quadrantal angle is an angle in standard position whose terminal side lies on the x or y axis. These are some examples of quadrantal angle. The terminal side lies either on the x or y axis. Examples. Determine whether each angle is a quadrantal angle. This is not a quadrantal angle. It is not in standard position. Although the terminal side lies on the y-axis, the direction of the arrowhead is not pointed at the terminal side. Pero pag ganito ang direction ng arrowhead and the terminal side lies on the y-axis, then this is a quadrantal angle. Another example. This is also an example of quadrantal angle. Its measure is 360 degrees. The initial side and the terminal side coincide with each other. This angle is not quadrantal since its terminal side does not lie on the x or y axis. So that is a quadrantal angle. How about coterminal angles? Coterminal angles are angles that are both in standard position and have the same terminal side. For examples, angles A and B are coterminal angles. They are both in standard position and have the same terminal side. Angle A is a positive angle while angle B is a negative angle. However, angles C and D are not coterminal angles. Why? Because angle D is not in standard position. The initial side is not located on the positive side of the x-axis. Examples. Determine the measure of the smallest positive angle coterminal with a given angle. So we're gonna determine the smallest positive angle coterminal with a given angle. Example, 42 degrees. First, Draw the angle measuring 42 degrees. Then, find the smallest positive angle coterminal with it. Since smallest positive angle ang ating hinahanap, the direction of rotation should be counterclockwise and we're gonna stop at this terminal side. And the measure of this angle is 402 degrees. One complete revolution is 360 degrees. Plus this angle, which measures 42 degrees, is equal to 402 degrees. And this is the smallest positive angle coterminal with 42 degrees. Letter B, the angle is negative 213 degrees. So it's a negative angle. And this is negative 213 degrees on the Cartesian plane. The smallest positive angle coterminal with negative 213 is 147 degrees. Again, since smallest positive angle ang hinahanap natin, pa-counterclockwise ang direction and we must stop at the terminal side of the given angle. Since this is the terminal side, kaya hanggang dito lang tayo kasi smallest positive angle ang hinahanap natin. Remember, one complete revolution is 360. Since the given angle is 213 degrees, we need 147 degrees to complete the 360. For letter C, negative 55 degrees looks like this, and the smallest positive angle coterminal with it is 305 degrees. If we add 305 and 55, it is equal to 360 degrees. So that is how you identify coterminal angles. What about reference angles? The reference angle for a given angle is the positive acute angle formed by the terminal side of the given angle and the x-axis. So if angle A is the given angle, angle R is its reference angle. Positive acute angle, which is less than 90 degrees, formed by the terminal side and the x-axis. Examples. Let us find the reference angle of the following. Letter A, 42 degrees. If this is the angle, the reference angle is also 42 degrees. Hindi pwedeng ito ang ating reference angle because it is no longer an acute angle. For 221 degrees, the reference angle will be this one, an acute angle formed by the terminal side and the x-axis, and this measures 41 degrees. Half of 360 is 180 degrees. If this angle is already 180 degrees, how much more do we need to complete 221 degrees? That is 41 degrees. 180 plus 41 is 221 degrees, and 221 minus 180 is 41 degrees. For letter C, the given angle is 113 degrees. The reference angle is 67 degrees. This is 90 degrees, while this part is 23 degrees, a total of 113 degrees. Para mag 90 degree ang measure dito sa side na ito, we still need 67 degrees, or subtract 113 from 180. So that's how you determine the reference angle of a given angle. Now, let's talk about the units of angle measure. There are three units of angle measure that are commonly used: revolution, degree measure, and radian measure. A revolution is formed when the initial side of an angle rotates completely around its vertex. Consequently, the angle's terminal side and initial side coincide. To one complete rotation of a ray, or to a revolution, 360 degrees is assigned. 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. This is the minute symbol, while this is the second symbol. Examples. Change each angle in decimals to minutes and seconds. For 22.4 degrees, we separate the whole number part, which is 22 degrees, from its decimal part, and multiply it by 60 to determine the value in minutes. So we copy 22 and multiply 0.4 by 60. And that is equal to 24 minutes. So 22.4 degrees is equal to 22 degrees and 24 minutes. For letter B, we also separate 14 from its decimal part and multiply it by 60. we have 14 degrees plus 12.6 minutes. 0.21 times 60 is 12.6 minutes. Since meron pang decimal dito, we also separate 12 minutes from its decimal part to convert it to second by multiplying it by 60. We have 14 degrees plus 12 minutes plus 0.6 times 60 seconds. And 0.6 times 60 seconds is equal to 36 seconds. So 14.21 degrees is equal to 14 degrees, 12 minutes, and 36 seconds. On the other hand, 1 radian is the measure of a central angle subtended by an arc of a circle that is equal to the radius of the circle. If the radius of a circle is 1 radian, the circumference of the circle, which is 2 pi r, will be equal to 2 pi radian. But a circle subtends an angle of 360 degrees. Thus, 2 pi radian is equal to 360 degrees. Divide the equation by 2, we have pi radian equals 180 degrees. Divide further the equation by pi, and we have 1 radian is equal to 180 degrees over pi. For degree measure, 1 degree is equal to pi over 180 degrees. So this is the process of converting degrees to radians and vice versa. To convert degree to radian, we multiply the number by pi over 180 degrees. While to convert radian to degree measure, multiply the number of radians by 180 degrees over pi. Examples. Convert each radian measure to degree measure. Letter A. Since the given value is in radian measure, we multiply 5 pi over 6 by 180 degrees over pi and simplify. 5 times 180 degrees over 6. 5 times 180 is 900 degrees. Divided by 6 is 150 degrees. Letter B. Also multiply negative 4 pi over 3 by 180 degrees over pi. Pag radian to degree, ang pi nasa denominator because our goal is to eliminate pi. So we have negative 4 times 180 degrees over 3. Negative 4 times 180 is negative 720. Divided by 3 is negative 240 degrees. How about if we convert degree measure to radian measure? Now to convert 45 degrees to radian, we multiply it by pi over 180 degrees. Nasa numerator na ang pi, while ang 180 degrees ay nasa denominator because our goal here is to eliminate the degree symbol. 45 degree times pi over 180 degrees is equal to 45 pi over 180. And 45 over 180 is equal to 1 over 4. Then just copy pi. Similarly, multiply negative 108 degrees by pi over 180 degrees and simplify. Negative 108 over 180 is equal to negative 3 over 5 times pi. And that's all about angles and angle measurement. Now, let us discuss the relationship between linear and angular measures of central angle. Linear measure of a central angle of a circle is the length of the arc of the circle that subtends the angle. This figure shows the angular measure of an angle theta and its linear measure s in a circle of radius r. On a circle of radius r, a central angle theta intercepts an arc whose length s is given by s is equal to r times theta, where theta is expressed in radians and s and r must be expressed in the same unit. So if we're looking for the linear measure or the arc length, we're looking for the value of s. And if we're looking for the angular measure or central angle, we're looking for the value of theta. Examples. Number 1. On a circle of radius 30 centimeters, the arc intercepts a central angle of 1/3 radian. What is the arc length? The given radius is 30 centimeters while the central angle or theta is 1/3 radian. We're gonna find the arc length or the value of s. Using this formula, we have s equals 30 centimeters times 1/3 radian. And 30 times 1/3 radian is equal to 10 centimeters. Number 2. Find the radius of a circle if a central angle of 110 degrees intercepts an arc whose length is 2 centimeters. The value of S is 2 centimeters, the arc length, while theta, or the central angle, is 110 degrees. But remember, theta must be expressed in radian measure. So we convert 110 degrees to radian by multiplying it by pi over 180 degrees. And that is equal to 11 pi over 18. So we're gonna find R. From this formula, we can derive the formula for the radius by dividing the equation by theta. Hence, R is equal to S over theta. Replace this with its given value and simplify. 2 divided 11 pi over 18 is equal to 2 times 18 over 11 pi, the reciprocal of the denominator. 2 times 18 is 36 over 11 pi. Therefore, R is equal to 36 over 11 pi centimeters. Number 3. Find the central angle that intercepts a 300 millimeters arc of a circle whose radius is 15 centimeters. We have the value of S, or the arc length, which is 300 millimeters, and a radius of 15 centimeters. Take note, S and R must be expressed in the same unit. If we're gonna use centimeters, we're gonna convert 300 millimeters to centimeters, and that is equal to 30 centimeters. 1 centimeter is equivalent to 10 millimeters. So 300 divided by 10 is equal to 30. Or, you can also convert 15 centimeters to millimeters to have the same unit with the arc length. Then, we're gonna find the central angle, or theta. Theta is equal to S over R. Replace S with 30 and R with 15. 30 divided 15 is 2 radian. Recall that theta is expressed in radian measure. Take note that 1 radian is equal to 180 over pi. So 2 times 180 over pi is equal to 114.591559. We can express this value into degree, minutes, and seconds. We have 114 degrees plus the decimal part multiplied by 60 minutes, and that is equal to 35.49354 minutes. We again multiply the decimal part by 60 seconds, and that is equal to 29.6124 seconds. So theta is equal to 114 degrees, 35 minutes, and 30 seconds. We round off the given value. Take note that the radius and central angle in a circle are also used to determine the area of a sector of the circle. If theta is the radian measure of a central angle of a circle of radius r, and if A is the area of a circular sector determined by theta, then we have A is equal to 1/2 times theta times r squared. Example: find the area of a sector of a circle with central angle of 120 degrees if the radius of the circle is 6 meters. Since theta is in degree measure, we convert it to radians by multiplying 120 degrees by pi over 180 degrees, and that is equal to 2 pi over 3. The area is equal to 1/2 times 2 pi over 3 times 6 meters squared. 1/2 times 2 over 3 is 1 over 3, times 6 squared is equal to 12 pi meters squared, or multiply 12 by the value of pi, 3.14, and that is approximately equal to 37.68 meters squared.